Hello everyone, this is K. Grishma studying engineering 3rd sem from SVC College, Bangalore. My subject is Digital Design and Computer Organization. Subject code is BCS302. My topic is concept of K-map, advantages and disadvantages. Let's look on the concept of K-map and advantages and disadvantages. Con- Contents are introduction, history of K-map, structure of K-map, create of a K-map, grouping techniques, don't K conditions, advantages, fast and simplification of process, limitations, errand prone for largest function, comparison with other methods, applications, tools for the K-map, creations, last but not least, conclusion of the topic. Introduction of K-map. K-map or Karunga map is a visual method for the simplifying Boolean algebraic expression. It allows minimization of logical functions, making it easier to design the circuits, especially the digital circuits. K-map are particularly useful for the functions with up to the 6 variables, although there can be extended even more, but 6 are the most required variables to be known. Let me look up the history of the K-map. K-map was developed by Marcin Koch in 1953 as a tool of simplifying logical circuits. It was introduced in the context of digital logical design. It has become the stable in the field. Understanding its history provides insight into the mathematical foundations and its applications. Structure of K-map. A K-map consists of a grid where each cell represents a mini term of a logical functions. The arrangement of cell follows the gray code, ensuring that only one variable changes between the adjacent cell. This structure allows for easy visual grouping of the terms for simplification. Once again, I repeat, structure allows the easy visual grouping of terms with simplification. How to create a K-map? To create a K-map, first we have to identify the number of variables in the Boolean function. Next, draw a grid based on the number of variables filling the cell corresponding to its output values. Finally, label the row with using the gray code to maintain the adjacents in the mini term. The next one for most required, the grouping techniques. K-map utilize grouping techniques to combine adjacent cell containing ones. Grouping can size be 1, 2, 4, 8, must be rectangular in shape. Each corresponding group is simplified and product in terms of final expressions. Let's look on don't K condition. Don't K condition allows the greater flexibility in simplification. These are the inputs that don't affect the output and treat neither it as a 0 or the 1 value. Including don't K condition can lead into the further minimization of logical functions. Advantages of K-map. K-map provide a clear visual representation of logical functions, facilitating easier and understanding. They allow the straightforward identification of simplification opportunity through the grouping. K-map can simplify a complex Boolean expression into simplest form, enhancing the circuit and efficiency. Let me repeat. The K-map provides a clear visual representation of logical functions, facilities easier understanding. They also provide the straightforward identification of simplifying opportunity through the grouping. K-map can simplify complex Boolean expression into the simplest form of enhancing circuit efficiency. Fast simplest process. The process of a simplification using the K-maps is a typical faster than the algebraic method. Visual grouping requires the code load, requires the identification of common term. This is particularly beneficial when we are working with the functions that may have a variable. The limitations of K-map. There are some of the major limitations which I looked at off. K-map cube sum of the functions which have more than 6 variables. As it is mandatory, which I told earlier, the more than 6 variables. The complexity of a larger map make it challenging to visualize, calculate the group in terms. This limitation can hinder their effectiveness in the extended digital designs. Errors The error for the points of larger functions. As number of variable increases, the likelihood of making the error during the grouping rises. Mistakes in visual grouping can lead into incorrect implications and faculty designs. This challenges reliability to the K-map when it dealing with the larger Boolean functions. Comparison with the other methods, K-map are often compared to the algebraic methods and computer-aided designs. While K-map provide visual approach, algebraic method may be some synthetic. Computer-aided tools can handle larger function more efficient than K-map. Practical applications of K-map. K-map are widely used in digital current designs for simplifying the logical functions. They are applicable in various fields including computer science and telecommunication. Understanding K-map is crucial for the students and professionally in electronic and circuit designs, especially for the electronic and circuit designs. K-map for SPOS. The SPO is a sum of the product and product of the sum. K-map is utilized for the both sum of the product and product of the sum. SOP involves this grouping of ones, while POS focuses on grouping on 0. Let me repeat. SOP involves grouping of ones, while POS focuses on grouping of 0. This versatility makes the K-map applicable to the various logical design scenario. Best practice of K-map using is start with a clear understanding of Boolean function to be simplified. Carefully label and fill the K-map to minimize the errors during the grouping. Utilize don't care condition while to achieve the most efficient simplification. Here are just a few examples which I'm going to show on the screen which for the K-mapping. The practical example are illustrated step by simplifying the K-map. Consider a simple function with 4 variables. Demonstrated grouping processes such as example of solidified understanding and providing the hands-on experience with the K-map. There are some few tools which we are looking on the screen for the K-map creations. Various software tools are available to create the K-maps digitally. This tool can automate the process of filling and simplifying the K-map. Utilizing such tools can enhance the accuracy and efficiency in logical design. Last but the least, conclusion of my own topic, the concept of K-map, it remains the valuable tool for simplifying the Boolean expression in logical designs. Understanding the advantages and disadvantages helps in choosing the right tool for task. Continued practice with the K-map will enhance one's proficiency in the digital logical design. There are the film references which we have go through considered by the textbook, references, research papers, additional tutorials. Thank you for watching my channel and keep doing the same approach towards me.